application, we see again types of triangles. We saw 30, 60, 90 triangle and its property application. We saw 45, 45, 90 triangle, its application. Now we see the most important triangle, which is an equilateral triangle. Okay, now let's see what is an equilateral triangle. All three sides are equal, A, and all three angles are also equal, which is equal to 60 degrees. Now what is it like? We'll study about equilateral triangle. Let's draw an altitude here. Altitude is nothing but height, altitude, median, perpendicular bisector, everything is same in an equilateral triangle. Okay, so I talk about altitude or a median or a perpendicular bisector, all of them are same in an equilateral triangle, and that is what makes this triangle very special. So if I am saying it's a median, what will it do? It will divide the opposite side, A into A by 2, A by 2. If I am drawing a perpendicular, I can say it is forming what now? 30, 60, 90. 30, 60, 90. So side opposite to hypotenuse is A. Side opposite to 30, I know it's A by 2. What will be side opposite to 60? Root 3 multiplied by the side opposite to 30. Root 3 A by 2. So I know first thing to derive is height of an equilateral triangle is root 3 A by 2. That is height. Okay. Area is what? Half into base into height. What is my base here? A. What is my height here? Root 3 by 2 into A. Okay, so what is an area of an equilateral triangle that we can derive? Root 3 by 4 into A square. So remember this formula, root 3 by 4 into A square. Now let's draw a circumcircle. Okay, outside touching the three vertices. What will be the circumradius? Okay, what will be the radius of this circle? Now remember this, will derive this. Median always divides in the ratio of 2:1. Okay, median is always divided in the ratio of 2:1, where 2 is always from the vertex and 1 is from the bottom. Okay, so that's how median is always divided in the ratio of 2:1, and this point is something called as circumcenter. Okay, which is the intersection of median. So what can I say? This is nothing but 2/3 of the height. 2/3 of height is nothing but root 3 by 2 into A. So circumradius comes out to be A by root 3. Remember that. Similarly, I'll draw an end radius. End radius means I'll draw an end circle inside the equilateral triangle. This is nothing but 1/3 of the height. Height is square root of 3 by 2 into A, and 1/3 of that will be nothing but A by 2 root 3. Now remember, mug up this formula. Circumradius A upon 2 root 3, end radius circumradius A by root 3, end radius A upon 2 root 3. Remember all this formula about this. Obviously your end radius is smaller, that's why divided by 2. Okay, and circumradius is larger, so A by root 3. That's what you have to remember about equilateral triangle. Now let's apply everything that we have learned in this equilateral triangle. Okay, what can we apply it here? So one equilateral triangle is given. The three sides of the equilateral triangle are 10, 10, 10. Okay, and I'm being asked what is the sum of area of all such equilateral triangle. Inside that there is an in circle, then there is a triangle, then there is an in circle to that, then there is a triangle, and so on. So I'll say the area of outer equilateral triangle is square root of 3 by 4 into A square, which is side square. Now the circle that is being drawn inside this equilateral triangle is nothing but an in circle, and what I am pointing it right now is nothing but its in radius. And we have just studied what is the formula of in radius of an equilateral triangle. We know that it is what? A upon 2 root 3. A is nothing but side, so side here is 10. So I'll write 10 upon 2 root 3. 5 upon root 3 is the in radius of the circle. Okay, of triangle ABC. So for triangle ABC, this is an in circle which has an in radius of 5 by root 3, but this is an circumcircle as well for the triangle PQR. Just see, it's an in circle for triangle ABC, yes, but it's in circumcircle for triangle PQR. Okay, it's in circumcircle. So if it's in circumcircle, what will it have? It will have a circumradius. So what is an in radius for ABC is an circumradius for PQR. You can imagine, just look at the figure closely. Okay, this will be a circumradius for PQR. Okay, and for circumradius for PQR, but it's an in radius for ABC. Okay, remember that. What is the formula for circumradius? Is nothing but A upon root 3, where A is the side of an equilateral triangle. So what is the side of an equilateral triangle PQR? Let it be B. I call it to be B. Then I'll find out what is B. If it is B, then it will be B upon root 3, correct? That will be the circumradius of PQR. Circumradius for PQR is an in radius of ABC we have derived, and that is nothing but equal to 5 upon root 3. So what will I write? this b upon root 3 will be equal to what? Phi upon root 3. In radius is equal to circumradius. Root 3 gets cancelled and I get my b to be as phi, which means the side of the equilateral triangle PQR is nothing but phi. Then if I just go in similar way, it will become half of that, 2.5, the side of an equilateral triangle which is inside PQR, and then so on. It will just go on, the side will become half and half till it goes to infinity. So what is the area of all such equilateral triangle? First 10 square, yes, then it will be 5 square, yes, then it will be 2.5 square, and so on till infinity, right? Square root of 3 by 4 into side square and so on for all this triangle, because the triangle will keep on going. This will form a geometric progression to infinity. If you have seen GP to infinity, this is of this type, 40, 20, 10, 5, will keep on reducing. So if I add all of them, what will be sum of the terms? I am saying the first term is 40 and the common ratio, that is second term upon first term, is half. So the sum is given as a upon 1 minus r. In this case example, I will write it as a, which is 40 upon 1 minus r. It's nothing but half, so the sum comes out to be 80. Okay, this is what we have studied in progressions. Now let's apply this GP infinite series formula to the same problem. So what will I do? I'll take out square root of 3 by 4 into 100 outside. So what am I left with? 1 plus 1 by 4 plus 1 by 4 the whole square plus so on till infinity. Why did I do in this way? Because I wanted my first term to be 1. When my first term is 1, it is easier for me to solve this problem. The calculation becomes easier, and that's why I took the whole of square root of 3 by 4 into 100 outside. Now if this is outside, this is nothing but GP, where the first term is nothing but 1, and the common ratio second term upon first term is 1 by 4. Sum of infinite to this GP is a, 1 upon 1 minus r, 1 minus 1 by 4. So it comes out to be what? 1 upon, if you can write this, 1 minus 1 by 4 is nothing but 3 by 4. It reverses and it becomes 4 by 3. 4 gets cancelled. The answer for this comes out to be 100 upon root 3, and that is your final answer. Sum of area of all this equilateral triangle is 100 upon root 3. That's an application of equilateral triangle.